Hello everyone. I'm glad to meet you on third international conference on sustainable future, environmental, technological, social and economic matters. The title of my paper is Stress Environment around head entries with pillarless gobside and retaining through numerical simulation incorporating the two types of fill-in wall. My name is Ivan. I'm one of authors of this paper. If you will have any questions, you can send them on email to me. This paper is divided on four parts. The first one is introduction, the second one is methods, the next one is result and discussion, and the last is conclusions. So well, the first part is introduction. At present, the depth of coal mines has reached 1,500 meters, a common underground coal mines technique that used today in a longwall method. In the longwall method, the overlying strata are allowed to cave behind the working face after the coal is extracted, creating a gob. Wide pillars in coal mines in Europe and Asia were replaced to narrow ones back in the 80s. Size of the narrow pillar in Ukrainian is generally from 1.5 to 3 meters, as shown at the top of the slide. In recent years, the pillarless technology was virtually developed as shown at the bottom of the slide. In this technique, the format enters artificial retaining as the tailgate for a next mining panel by using concrete block, paste-like backfill material, and other fill material. Many coal mines use a pillarless mining. As can see on slide, the gobside and retaining method requires installation of artificial fill-in walls. The mechanical properties of fill-in material largely determine on gobside gate rod stability. Usually, technologies that came out in a recent year have been applied in gobside and retaining engineering, as which roofs are managed using the caving method. But the high cost limits its wide application. In last year, was proposed the use of gangs as a fill-in wall material that can help remove gangs on the ground. This reduced the cost of fill-in wall and solved the problem of rocks wastes. Coal gangs is a concrete material utilizing gangs at a coarse aggregate and cement as a cemented material mixed with a certain amount additives. In this paper, based on a geological condition typical for Ukrainian Donbass, two variants of fill-in wall, height support cemented fill-in and gangs concrete wall were researched. This study provides a reference of which fill-in wall design of choose on the gobside and retaining for coal mines that have similar geological conditions. Okay, the next part is methods. Method of computer simulation was used to investigate straight field evolution around head entries. The general scheme of the model is shown in slide. The model is simulated geological condition typical for Ukrainian Donbass. In the numerical simulation model, the thickness of coal seam is 1.5 meter. Finite element analysis software system ANSYS was used. The modeling was carried out in the volume setting of the natural scale. To simulate the behavior of rocks, a Drucker-Prager deformation model was used. The geomechanical situation corresponded to the state of the massif behind the longwall after coal seam was excavated and the immediate roof collapsed. The finite element model is shown in slide. Initial date for numerical modeling, you can see a table. On the next part is the result and discussion. To study the stress of environment around head entry, simulation modeling of the deformation process was carried out. Main roof console length was varied from 18.5 to 57.5 meter. Three tasks were solved. You can see on the slide. Distribution of the maximum principal stresses around the head entries with 42 meter main roof console length are shown on the slide. Gray color highlights the area, then which the resultant stresses exceed the tensile strength of the roof. In the case of using creeps, the maximum of the principal stresses in main roof is on the coal seam side. Hence, probably to cutting of the main roof. When using filling wall, the maximum stress is above once, which contributes to cutting the main roof above the wall, and it's more favorable for the stability of the head entries. To quantify the influence of the type of filling wall or the localization in the area of maximum stress and the probable place of main roof cutting, the stresses in the console of the main roof were analyzed. The stress control points you can see in this image. Slide 7 shows graphs on change of the maximum of the principal stresses as the model along line 1 of main roof. Chart show that a decrease on the rigidity of the filling wall case creeps leads to shift extremum to side of gate rod towards the untouched massive. This increased the probable cutting of the main roof from the side of the massive. Thus, the fact that gun concrete can replace hard super cement when creating a filling wall is confirmed. An increase in the length of the console of the main roof, 18 for 57 meters, caused as increase in stress by 27%. Slide 8 shows that an increase in the length of the main roof console leads to an increase in stresses in the main roof, which is generally logical. The maximum influence of the console length of the principal stresses is observed in the section between 0.615 along line 1 that you saw in previous slide. That is the section between 0.615 along line 1. That is above the entry and the filling wall, where the maximum stress are formed. This influence naturally goes in the direction from entry to job. On slide 9, you can see how the location of the destruction of the main roof affects the condition of the roadway and the loading of the support system. When the stress extremum in the main roof relative decayed towards the untouched massive, the probability of cutting of the main roof from the side of the massive. In this case, the weight of the roof rock rests in the lining of the entry and leads to deformation, which does not allow saving the gate rod for reuse. Otherwise, when the maximum stress is one of side the group, cutting is observed above the filling wall, and the gate rods can be reused. Finally, the last part is the conclusion. It is shown that when using wooden creeps, it is impossible to achieve the use of gate rod since the convergence in the entries is too large. At the same time, gun concrete can replace hard super cement when creating a filling wall. With gun concrete filling wall, more favorable conditions are created in terms of stress in the roof. However, filling walls are only effective if there are cutting roof over them. If the cutting roof area is localized from the side of the rock massive, then the weight of the rock falls on the entry and critical deform it. Cutting of the roof from the gobside will only occur if compressive strength of the filling wall is higher than the main roof. This is end of my presentation. Thank you for watching and listening. I am waiting for your questions.